All right, this is a video on solving systems of equations with three variables, x and y and z. We'll start with a brief introduction and then go through three separate examples. This will be a little bit of a longer video, so I encourage you to maybe look at each of the three different examples separately, but you definitely want to make sure you do follow through each of the three different examples. So our goal when solving a system of equations with three variables is to find a point x, y, z, so an ordered triple, that works for three different equations. As a little bit of a visual introduction that I'm not going to solve, but I'll maybe get you to start thinking about and feel free to solve on your own, is this problem with scales here where we have three balanced scales with A's, B's, and then one 10-pound weight as well, and some C's also. Your job is to think about how much A, B, and C each separately weigh. Okay? So as a way of introducing what we're doing, you might realize that two A's are the same as B, so could you plug two A's in there? And three A's are the same as C, could you plug three A's in for C, and then perhaps solve for the weight of A and complete the problem from there. But let's start with these three different examples we're doing. And so here's the first one. We're going to try to solve it using elimination. And so you can see we have three different equations here with an x, y, and z in each of them. My biggest piece of advice for you is to not rush into these problems, but just look at them for a moment, maybe even 30 seconds, and just really think about what variable might be easiest to eliminate first, what your strategy might be. Okay? And so hopefully you can see here that we can eliminate the z's relatively easily first, and then our intermediate goal is to get a system of two equations with two variables, x and y. So I am going to not show you every single step of my work, but I will definitely speak through my work and describe it verbally. But we're going to add those two equations together, the top two equations, and also, by the way, let's number our equations. That'll help us down the road stay organized. So we're going to add equations 1 and 2 together. And that'll give us equation 4. Okay? And when we add those two together, we get a 3x and we get a minus y plus 3y is plus 2y. The z's eliminate, equal to 15. Okay? Then I think you can see that we can add 1 and 3 together, and z's will also eliminate. And so let's go ahead and do that. And we'll get a 6x. And you can see our y's eliminate as well when we add 1 and 3 together. So y's and z's will both eliminate. 6x is equal to 18. Okay, so just to be clear, I added those two equations together to get that equation I just wrote down. 6x is equal to 18. And that, by the way, we can call equation 5. Using equation 5, we can solve for x, divide both sides by 6, and get x is equal to 3, which is great news. And we'll circle that so we remember to come back to it. Now that we know x is 3, we can plug in that 3 for x into any other equation that has an x in it. But let's be strategic and plug it into equation 4 so that we can solve for y. We're not ready to solve for z yet. So equation 4 is going to turn into 3 times our 3 for x plus 2y is 15. 9 plus 2y is 15, so 2y is 6, meaning y is also 3. Okay, so we've gotten through a lot of the problem already. We know that x is equal to 3 and y is equal to 3. We just need to solve for z. So we can pick any equation with a z in it. Let's be strategic and pick one that's maybe a little bit easier, although these are all look pretty comparably easy. I'm going to choose equation 1. Okay, so equation 1, we can plug in x as 3 and y as 3. 2 times 3 minus 3 plus z equals 4. Now we can go ahead and solve for z. 6 minus 3 is 3 plus z equals 4. 3 plus something equals 4. I think it's clear that z is equal to 1. So we've solved it. Let's write out our answer as an ordered triple. x, y, z, 3, 3, 1 would be our solution to this system of equations. All right, let's go ahead and try example number 2, which will get a little bit more complex, but I think we'll still be able to do it. And again, my big suggestion is that you pause and look through the equations, see if you notice any patterns, see if you notice anything that will help you down the road. So what I'm noticing are that either x's or y's might be easiest to eliminate first. Okay, and I'm going to choose x's. So I am going to multiply the top and the bottom equations each through by 2, and I think you'll see why I'm doing that in a second. So I end up with a 2x plus 2y plus 4z is equal to 6. And for my bottom equation, I'll get a negative 2x minus 4y plus 2z is equal to 20. And I can just bring my middle equation over so I have a fully new set of equations that work. 2x plus y plus 3z equals 7. Let's go ahead and number them real quick so that we can continue to work with them. And this is still number 2, by the way. We didn't change it, and that will be equation 5. So I'm just labeling them, numbering them. Put your numbers in circles so you don't accidentally think those numbers are part of the equation itself. I am going to add 2 and 5 together. And I think you can see that my x's will eliminate. Okay, so let's go ahead and do that. We have a y minus a 4y gives us a negative 3y plus 5z equals a 7 plus 20 is 27. Okay, so I'm going to box that so I remember to come back to it. I'm going to try to work with another couple equations to get an equation in just y and z with x eliminated. And it looks like we can do that with equations 4 and 5. So we can add equations 4 and 5 together and get a new equation that has x eliminated. So the x's will eliminate 2y and a negative 4y. So just to be clear, I'm adding these two yellow equations together. 2y and a negative 4y is a negative 2y. 4z and a 2z is a 6z. And 20 plus 6 is 26. All right, so I have a couple equations now with just 2 variables in them, a y and a z, and we can do our typical work of solving a system of 2 equations with 2 unknowns, just like we've done. We've practiced that a lot. So I am going to think about, do I want to eliminate the y's or the z's? Let's eliminate y's. I'm going to multiply this through by a negative 2 times a negative 2. And I'm going to multiply the second one through by 3. So let's go ahead and do that. And that will give us, let's number some of our equations. Let's get caught up. This is equation 6. This is equation 7. So our new equation 8 will be 6y minus 10z equals negative 54. And our new equation 9 will be negative 6y plus 18z equals 26 times 3 is 78, I think. Yep. And I think you can see if we were to add these 2 equations together, our y's would eliminate. So this will be equation 10, and equation 10 will allow us to solve for z. So our y's eliminate. Negative 10z plus 18z is 8z. And 78 and a negative 54 is a 24. Okay, divide both sides by 8 and z equals 3. So that's good news. We have z solved for. And now we can go back to any of our other equations and work on solving for x and y. Let's solve for y next because equations 6 and 7 both had just a z and a y in them. So let's work with equation 6, how about? And we can plug in z equals 3 into that equation. Negative 3y plus 5 times 3 equals 27. Negative 3y plus 15 equals 27. Negative 3y, subtract 15 from both sides, we get a 12. So y is a negative 4. So we're making some progress. It's a long problem, but we're getting closer. So now we know that z is 3 and y is negative 4. So we can take any equation that has a z and a y in it and work on solving for x. And let's take the simplest equation, which is equation 1, way back up at the beginning, where we were told that x plus y plus 2z equals 3. So we will take both of these guys and plug them into equation 1. By the way, equation 1 said x plus y plus 2z equals 3. So let's plug them in. So x is still unknown. Y is negative 4. 2z is 2 times 3, and that all has to equal 3. So let's work on solving. X minus 4 plus 6 is plus 2, equals 3, so x equals 1. Phew, we solved that one. That took a while, but now we have an ordered triple, x, y, z. So x is 1, y is negative 4, and z is 3. That would be our solution to this system of 3 equations. Key thing there that we did on that one is we didn't rush into it. We paused and realized that we could eliminate x's early on, and we needed to multiply a couple equations by 2 to eliminate those x's. All right, one last one, and I'll try to model using substitution here. Okay, so again, let's number our equations, 1, 2, and 3. And let's turn equation 2 into equation 4 by isolating for x. So let's say that x is equal to negative 5y plus 9. So now that we know that x is negative 5y plus 9, we can take that and plug it in wherever we see an x in any of the other equations. So I'm going to rewrite equation 1. 2 times negative 5y plus 9 plus 3y minus 2z equals negative 1. Let's do some simplifying. Negative 10y plus 18 plus 3y minus 2z is negative 1. Combine the y's together and subtract 18 from both sides. We have a negative 7y minus 2z equals negative 19. Okay, let's circle that. And let's, by the way, call that equation 5. Okay? There's no like hard and fast rule about how to label your equations, but the more you label, the easier it's going to be. So equation 5 looks like we have an equation with just a y and a z in it. Let's work with equation 3 now to plug in our negative 5y plus 9. So remember, 3 started out as 4z minus 5x, but now it's 4z minus 5 times now what we know x to be, all equals 4. So we just plugged in x right in there, or plugged in negative 5y plus 9 as equal to x. So let's go ahead and do some simplifying. A 4z plus 25y minus 45 equals 4. Okay, I'm going to do a couple things. I'm going to rearrange the y and the z so that it lines up with our y and z in that equation eventually. And then I'm also going to add 45 to both sides. So we have 25y plus 4z equals 49. And let's call that equation 6. Another big suggestion on these is don't try to save paper, okay? Really try to write, use a full piece of paper, write out all the work you need to do. It'll be much easier down the road. So don't try to do a lot of this in your head. Don't try to save paper. There's definitely want to be using lots of space here. Save lots of space for yourself. So let's put these couple equations together. So we have a negative, so we have 5 here is negative 7y minus 2z equals negative 19. And let's try equation 6 times a, actually let's multiply equation 5 through by 2. Okay, so let's undo some of that work I just did. Let's multiply equation 5 through by 2. So this is 5 times a 2. And we get a negative 14y minus 4z equals negative 38. And let's multiply, or just bring equation 6 down. We have 25y plus 4z equals 49. And I hope you can see that we can add these two guys together. Z's will eliminate, and we'll call that equation 7. We'll get 25 minus 14, 11y, 49 minus 38, 11y equals 11, so y is 1. Phew, that took us a while, but we're not done yet, but now we know at least that y is equal to 1, so that's good news. We can then start plugging in y is equal to 1 into any other equation we like. I like equation 6, it's a pretty simple equation. So working with equation 6 next, Now that we know that y is 1, 25 times 1 plus 4z equals 49. Subtracting 25 from both sides, 4z equals 24. So z is equal to 6. I feel like we're getting close here. Okay, we're getting close. We know y, we know z. Let's try to find x. So we need an equation with an x, y, and z in it, and that's one of our first equations. And let's just use our actual equation 4, had x isolated for. Okay, back at the very beginning, equation 4 has x all by itself. So equation 4 says that x equals 5y minus 9. Is that right? Negative 5y plus 9, my mistake. Negative 5y plus 9. And so let's just plug in what we now know, that y is 1. Negative 5 times 1 plus 9. So x is equal to 4. So we did a whole lot of work, and we have an ordered triple now. X, Y, Z, 4, 1, 6. Phew, we did it. That was a long one, but we got through it, and that's a good place to stop.